Okay, so today in geometry, we're going to start section 3.3, but we're going to review section 3.2. And we're looking at using parallel lines and transversals and applying the postulates and theorems. So let's just recall from last week the postulates and theorems. The alternate interior angle theorem: if a transversal intersects two parallel lines, then alternate interior angles are congruent. The corresponding angles postulate: if a transversal intersects two parallel lines, then corresponding angles are congruent. The consecutive interior angles theorem: if a transversal intersects two parallel lines, then same side interior angles or consecutive interior angles are supplementary. And then the alternate exterior angle theorem tells me that if a transversal intersects two parallel lines, then alternate exterior angles are congruent. All right, so we're going to look at first what postulate or theorem justifies the statement about the diagram. Okay, so number one, it says angle 1 is congruent to angle 5. So angle 1 and angle 5, they both sit to the left of the transversal and on top of a line. So this is the corresponding angles postulate. So corresponding angles postulate. Number 2, angle 4 and angle 6 are supplementary. So we're looking at angle 4 and angle 6. They're on the same side of the transversal, so they are consecutive. So this is the consecutive interior angle theorem. Number 3, angle 4 is congruent to angle 5. So angle 4 and angle 5 are alternate interior angles. So alternate interior angle theorem. And finally, angle 2 is congruent to angle 7. So angle 2 up here and angle 7 down here, those are alternate exteriors. So alternate exterior angle theorem. Okay. Again, from last week, review, find the missing measures of 1 and 2. Okay. So I have 120 degrees here. I know that angle 1 is a vertical angle from that. So the measure of angle 1 is 120 degrees by vertical angles. And then angles 1 and angle 2 are corresponding. They sit in the same spot. They're both to the right of the transversal and on top of a line. So that means that they are congruent. So measure of angle 2 is also 120 degrees. All right, the next one, we have this line continues on out, as does this one. So I have 60 degrees. 1 and 2, 60 degrees and angle 2, they are corresponding. They're both sitting in the same spot, so I know that they are congruent. So the measure of angle 2 is equal to 60 degrees. And then I can use that angle 1 and 60 degrees are a linear pair, which means they have to add together to equal 180. So measure of angle 1 is 180 minus 60. So the measure of angle 1 is 120 degrees. All right, next one, find x and y. And missing in the picture here, this is a right angle. Okay. So now I know that that right angle and angle x, together they form a linear pair. So together they have to equal 180. So then the measure of x is equal to 90 degrees. X and y are alternate exterior, so they are congruent. So y is also 90 degrees. This next picture, again, this line goes all the way across. So I have 3x and 120. Again, I see that they are on the same side of the transversal and they are both below a line. So they are corresponding, which means they are equal. So I would say 3x equals 120. Divide by 3, so x is equal to 40. No degree sign because x does not represent an angle. That's all review from last week. So now let's look at the new stuff, 3.3. This is how we're going to prove that lines are parallel. So we have different ways to prove two lines are parallel. Number 1, we can show that corresponding angles are equal. Number 2, we can show that alternate interior angles are equal. We can show that alternate exterior angles are equal. We can show that consecutive interior and consecutive exterior angles are supplementary. Okay? The converse of the 4 theorems provides you with 4 ways to determine if two lines are parallel. So the converse of the alternate interior angles theorem tells me if two lines in a transversal form alternate interior angles that are congruent, then I can say the two lines are parallel. Remember that the alternate interior angle theorem told me that if I had two lines parallel, my alternate interior angles were congruent. So this is just going backwards. So now if I know that the alternate interior angles are congruent, I can then say that the lines are parallel. Converse of the corresponding angles postulate again tells me that if the two lines and a transversal form corresponding angles that are congruent, then I can say the lines are parallel. Converse of the consecutive interior angle theorem, if two lines and a transversal form same side or consecutive interior angles that are supplementary, then I can say that the lines are parallel. And the converse of the alternate exterior angle theorem, if two lines and a transversal form alternate exterior angles that are congruent, then I have enough to say that the two lines are parallel. Then we also want to talk about the transitive property of parallel lines. So this tells me if two lines are parallel to the same line, then they are parallel to each other. So in this picture, I have lines P, Q, and R. I could say if line P is parallel to line Q, and line Q is parallel to line R, then line P is parallel to line R. Transitive, remember that that's just like our chain rule. So I go P to Q, Q to R, I can go P to R. All right. All right, so now let's look at some problems involving this stuff. So find the value of X that makes M parallel to N. So we want to prove M and N parallel. In order to do that, I look at what types of angles do I have. They're both to the right and on top of a line. So these are corresponding. So the converse, okay, so I'm going to write down what we're doing. The converse of the corresponding angle postulate is what we're using. It tells me that if these two are congruent, then the lines would be parallel. So I would say 3x plus 5 equals 65. Solve this, I move my 5 over, so I get 3x equals 60. And divide by 3, x is equal to 20. So when x is equal to 20 by the converse corresponding angle postulate, then I could prove that M is parallel to N. So then therefore, M parallel to N. All right. Again, find X so that S is parallel to P and identify the postulate of the theorem that we used. So I see 2x minus 20 and 3x minus 70. These are alternate exterior. So we're going to use the converse of the alternate exterior angle theorem. So set them equal to each other. So 3x minus 70 equals 2x minus 20. Get all of my x's on the same side. So I'm going to move 2x over. So I get x minus 70 equals negative 20. Add 70, so I get x is equal to 50. So when x is equal to 50 by the converse of the alternate exterior angle theorem, I could then say that S is parallel to P. One more example of this. So I have 3x minus 60 and 2x plus 10. These are alternate interiors. So I would be using the converse of the alternate interior angle theorem to set these equal. So 3x minus 60 equals 2x plus 10. Again, get all of my x's on the same side, so I'm going to subtract 2x over, and then I get x minus 60 equals 10. Add 60, so I get x equals 70. When x is 70 by the converse of the alternate interior angle theorem, I could say that line S is parallel to line P. So that's a review of some 3.2 stuff and the very first day of 3.3. All right, and tomorrow we will be taking our quiz over sections 3.1, 3.2, and the very first part of 3.3 that we just talked about, as well as the vocabulary, which will contain chapter 1, chapter 2, and chapter 3 vocabulary up to this point.